Mhm. Yeah.
21, 23, 25, 29, 31. What is that? 0, 2, 4, 6, 9, 13, 21, 23, 25.
A very good morning to one and all present here. It's an immense pleasure to thank everyone who has shown interest in this workshop on process design and development conducted by the Department of Mechanical Engineering in association with IIC and EDC. The best way to start a program is the way to start it with a smile. Now I would like to call upon Mr. Sugandhan from second year Mechanical Engineering to present the welcome address.
A very good morning to all. I am honored for giving the welcome speech on the occasion of the guest lecture on workshop on process and design and development. I feel privileged in welcoming our esteemed chief guest, Dr. K. Karthik Selvakumar, Assistant Professor, Department of Green Energy Technology, Madanji School of Green Energy Technology, Pondicherry University, a central university under Minister of Education to this workshop. Your valuable inputs will definitely light a spark of motivation to the audience. Welcome you, sir. I feel deep pleasure in welcoming our Director Administration, sir, to this program. Welcome you, sir. I feel great pleasure in welcoming our Principal, sir, to this workshop. Welcome you, sir. I feel happy in welcoming our IQAC head, Dr. K. Sundaramurthy, sir, to this workshop. Welcome you, sir. I feel very glad in welcoming our HOD sir to this program. Welcome you, sir. I feel happy to welcoming our faculty members and students of Mechanical Engineering Department and other department IIC, EDC students for coming to take part in this workshop. Once again, welcome you all. Thank you.
Thank you, brother. I wish to welcome Mr. Shyam Kumar from second year Mechanical Engineering to give a glimpse about the guest lecturer.
Good morning to one and all present here. I feel extremely proud and privileged to introduce our dynamic chief guest, Dr. K. Karthik Selvakumar, Assistant Professor, Department of Green Energy Technology, Manjit School of Green Energy Technology, Pondicherry University, to this enthusiastic student workshop. Dr. K. Karthik Selvakumar has completed his UG program in DSA Crescent Engineering College, Chennai. He had completed his master program in M.Tech Production Engineering, Tanjavur College of Engineering, Madurai. He had completed his PhD in Fluid Structure Interaction in Indian Institute of Technology, Dhanbad, India. He had also completed his postdoctoral fellowship, Indian Institute of Technology, Guwahati, Assam, India. He had published 14 Scopus Index Journal and 14 international national conference, including 2 Scopus Index, and also published 3 books and 4 international book chapters. He had completed funded projects in title of design and development of PSA based oxygen concentrator with amount of 2 lakhs from the funding agency Newgen IEDC DST. His ongoing funded projects in the title of design and development of cost effective ocean wave energy conversion system with amount of 8 lakhs, including 1 junior research fellowship from the funding agency IIT Guwahati. He has completed the funded 1-week high-end workshop Karyashala awareness on sustainable energy management and harvesting technique with the amount of 5 lakhs from the funding agency DST served in Pondicherry University. Thank you all.
Thank you, brother. Now I wholeheartedly hand over the session to the invitee.
I think I hope you are seeing the slides.
Yes, sir.
Okay. First of all, I'd like to thank the management of Paavai Engineering College and the head of the department and the person of in charge coordinator for the organizer for this event. So, like today we are going to, before the presentation, like in my introduction, small correction is there is Tyagaraja College of Engineering, that is not Tanjavur College of Engineering. So that, okay, nothing else. So before getting into the topic, today we are going to present on application of CFD on unmanned aerial vehicle for basically drone design. This I have done in MNRE earlier somewhere I have presented. So I thought to provide this type of workout for you people. So it can be very useful for in different area for defense and different applications. So before getting into the topic, the slides are not moving. Okay. So before getting into the topic, our department is engineering background department, that is green energy technology, in which we are handling photovoltaic, bioenergy, green buildings, solar thermal, energy materials, conversion, wind, ocean, and tidal. So along with the computational aspect of everything. So that last part, wind, ocean, tidal, along with the computational aspect, I have been handling. So, and we have a M.Tech program of green energy technology. That is, we have a SAP funding. So who are joining first 4 students from India, they will get a complete relaxation of scholarship throughout the fees relaxation and hostel fees, many things. Contingency also will be there, and monthly stipend of 13,000. So 4 person can from mechanical engineering background, electrical, electronics, they can join in our department, even civil department, civil engineering. So that is one of the opportunity if anyone want to pursue further M.Tech program. So apart from that, now we are going to organize like start a B.Tech program recently because of that NEP. Everyone has to be focused on NEP based program. We are starting newly from this August B.Tech Energy Science and Technology. So that is of our department. So now what happened? We have to go with the drone design and analysis. Why we have to design the drone? Why we have to? What is the importance of designing the drones and everything? So what are the application? Any of you can give your opinion. Otherwise, I will just move forward. So recent days, there is a significant importance of drone design has been significantly increased. So from domestic, from toy to domestic application, or you can go for any events or anything, the drones are playing highly vital significant role in that shooting of video or multiple things. And in Dubai and some other places, they started carrying the utilizing it for logistic management, carrying the product from one part to another part. So recently, some 1 year back or 2 year back, our DRDO, they have called for a project call for. So that is about what? Development of drones that can be having a high payload capacity. So what is high payload? Any one of you? The payload basically it depends upon the load carrying capacity of the particular drone design. So it may have to carry either that food supply or logistic. Along with, other than that, it can be useful for as a spy camera. Then additionally, in additional what, it can be carrying the weapons. So multiple usage, and it must possess the characteristics of carrying multiple loading application and weather conditions. Okay. When you go for certain heights and certain climatic condition, it has to withstand the phenomena of what, that climatic phenomena. So mostly what happened, we are traveling against the flow nature. So what exactly it is? It is about the phenomena is called fluid structure interaction. When a fluid and structure is interaction, multiple phenomena will happen. So fluid elastic instability will happen. Fluid elastic. So the designing aspect of any vehicle, from your high-end sophisticated cars to any automobiles or any like a flight system. Okay. So we have to think about more aerodynamics and other aspect. We have to think about when, because it is going to interact with the fluid. That fluid may be when we are saying about unidentified like unmanned air vehicle, what it can be there. It can be utilized for your underground water, okay, exploration. That can be a submarine, unmanned way, and instead of unmanned aerial vehicle, we can utilize the same concept for like underground, yeah, aerial underground vehicle. Okay. So unmanned underground vehicle that can be useful for exploring the ocean structure, ocean based. Okay. So that will be not covered in this section. We are only dealing with the aerial drone. That drone can be, because that will be a submarine part. So vehicle, so unmanned vehicle, in unmanned vehicle, we are dealing with only aerial vehicle aspect. So that of drone, that drone may be classified into multiple type of drone, depends upon the rotor system. It may have a and lifting, vertical lift, and similar to your aeroplane or anything. Okay, flights. There is a drone systems already has been employed in different defense sector to carry the weaponized, okay, weapons. So you may have seen in multiple foreign movies, or you can see different. You read the different zone war news about many things. So what happened? The drones has been dropped multiple bombing at different place, because in order to avoid the like loss of human lives for the attack, and it has to perform the effective operation. Okay. So like that, the drones has been utilized in many aspects. So now what happened? When you go for a design consideration of unmanned aerial vehicle, what are the things we have to consider? What are the theories will be background? So what will happen? We are focused on computational fluid dynamics, okay, fluid structure interaction. So basically, it will depend upon the computational fluid dynamics. Then what? There is a two different things are there. That has to be some theoretical background or theoretical laws. Theoretical has to be behind that your operations. So what are the theory? When you go for a design, you have to design what is the need. Mainly when you go for any product development, what we will do, we will go for first that need of the customer or end user. So with respect to the end user, we will design a particular component or any product. So now what happened? We have a theories and methods. So what are the theories and methods? That is a, when you design any drone design, you have to think about linear aerodynamics, steady aerodynamics, okay, aircraft trim, sustained turn, okay, vortex lattice method, drag component buildup method, and what happened? Computational fluid dynamics CFD and turbulence in CFD. Okay. So now when we go for a methods, what will be there? There is a vortex lattice model or method. Okay, it will be like a model or method. Then computational fluid dynamics modeling and analysis. So why we have to do this thing? Earlier day we have utilized the experimental model prototype developed. Then we will be analyzing in a different wind turbine or wind tunnels. What will happen? Wind tunnels, we will focus on different aerodynamic profile. What happened? It will be taking a lot of time, and you will have to create multiple prototype. If anything has to be changed, any particular dimension or anything has to be changed, what happened? We have to do it again, and we have to analyze it. So where there is a lot of why the computational aspect is more higher in recent years. It will be what? Cost effective. It will be process effective. It will be what? It will be finally you will get to the product. Only thing you have to work out, the time will be maybe time consumption when comparing to manufacturing a product and testing it. You can do it in a like computational stage testing analysis using different software. You know, as a mechanical engineer, we know we can multiple softwares are for there for designing a component. SolidWorks, Creo, like Creo or Cataya, or multiple three-dimensional softwares are there. Then what happened? Combined together, we assemble together the component. What will happen? We will give it to ANSYS for analysis. If it is a commercial software, if it is going for open form software, what we can do, we can utilize this open form version. Okay, open form, different coding and everything. Python coding also nowadays, more and more codings are there. You can do it. So multiple options are there now. But before going into this commercial version or coding and open form, we have to know the basic theory. What is the basic theory behind it? You have to understand the aerodynamics, whether it is a linear aerodynamics or steady state aerodynamics. Then what are the things has to be do? Aircraft trim, how it can be done, sustained turn. When a flight is your drone or your object, it is flying in a aerial zone. What will happen? It has to take a sustained sudden turn without change of your altitude. Okay. So now what happened? Your drones are moving in the border of enemy border. What will happen? It has to be move away from the border in a quicker manner. Otherwise, it will be attacked. What will happen? So there has to be a sustained turn or sudden turn. It has to be taken away without affecting the stability of the plane. Okay. And without changing the altitude of the plane. Okay, how it can be designed. So many things are there. Okay, so that has to be taken into consideration when you have going for a designing of a particular component. So now what happened? What is the linear aerodynamics? Linear aerodynamics is nothing but we have to apply the effect. Okay, non-linear aerodynamic effect cannot be neglected. There will be always there is a non-linear effect in all the parameter. But linear aerodynamics, what happened? It has to be investigate small angle of attack. So there is a small change. This angle of attack, where it will happen? It will happen in the wings of the your blade. So your wings of the blade will design the lift. What are the coefficients will be there? Different coefficients, drag, lift. Okay. So different coefficient that will define your that lift and drag option of your particular flow phenomena. So aerodynamic profile, that is a aerodynamic forces will be there, drag force, lift force. So it will be depend upon your angle of attack. It may have a 0, it may have a 15, it may have. So when it is going for 45 degree, it will become stall. What will it will stop at the particular, the flow may not be past the particular thing because it may like a hitting the wall of the particular zone. So what happened? Linear aerodynamics often used as a first approximation, earlier phase of your design. So what happened? It has to be used for the analyzing the performance and characteristics of the aircraft due to its low computational version. So when whatever we do any condition, what it represent when we do earlier design, we are going to design a particular component, particular product, and you are analyzing in a computational zone. Initially, you will analyze without the disturbance. Okay, there won't be any disturbance in that. So smoother analysis, linear algebra. When you go for mathematics, linear algebra, everything you will do. So what happened when you go for? You have to understand the after effect. If some disturbance or some perturbation in the flow, what will happen? It may causes the overall flow dynamics. So that also it has to be analyzed the non-linear aerodynamics. Okay? So that can be done. Initially, you have to go for a initial linear. So that steady state of aerodynamics. Your steady state of aerodynamics, which will depend upon what? There will be a lift force because your vehicle has to be traveled in the air. It has to be lifted from your ground. So there has to be a lift force. Then drag force. So drag will be consist of multiple drags will be there. So what are the drags are there? Parasitic drag. That parasitic drag will be called form drag, skin drag, and interference drag. Okay. So then lift induced drag will be there. Then thrust and weight forces, which will be different forces are there, and along with the different drag and lift coefficients will be there. So what will happen? Parasite drag, parasite, what will happen? It will attach to your body. Okay. Like your flow phenomena happening, the drag which will depend upon the structure of your particular product or that aerodynamics. So now what happened? We have a thrust. Thrust will be happening when your object is moving towards and the against the particular flow. Your lift, which will has to be lift the object. So you will change the aerofoil profile and angle of attack, and the motion will be considered that the flow of your motion of your particular aero drone, which will be supplied with respect to the input like a flow behavior. Okay, you have an engine or a gas chamber that so it will what happen? It will initial push it will give, but it when it will be lifted, it needed a aerofoil. Aerodynamics forces has to be played on that. Okay, so when you are lifting and when you are ascending, okay, so what will happen? You needed the forces has to be playing a crucial role on your drone designs. So what will happen? We already know there is a multiple number of your particular flow phenomena will be there. How flow phenomena, if it is disturbed. So now what probably they are putting a plate in a particular zone in a flow path. So
Hello, excuse me, sir. Sir, உங்களோட மியூட்ல இருக்கு சார். அப்படியே அன்மியூட் பண்ணுங்க.
from starting itself it is mute or what?
Not like this, sir. Just now, sir.
I have didn't done any mute. Okay, no issue. Okay, that earlier version you have seen or not? This portion you have seen or what?
Yes, sir.
Okay, now that different forces has to be, you have to consider main forces are that lift, drag, thrust, okay. So and weight, and apart from that, the drags will have a multiple or significant role in your reduction of the speed and reduction of your lifting capacity of the any object when it is interacting, when a fluid structure interacting. The drag phenomena, what are the drag phenomena which will be there? There is a different parasitic drag. That parasite will form, that is a form drag, skin friction, okay, skin friction and interference drag. So each will have a certain limitation will be there. So now what happened? The shape and object of the flow, what will happen? There is a form drag is very less. But when it is going for a different object oriented, what will happen? There is a form drag which will have a more number of percentage which will be affecting your particular zone. Okay. So now what happened? Trimmed aircraft. What is the trimmed aircraft? What happened? You have to design a flight with respect to reducing adjust the aerodynamic forces. With respect to adjusting aerodynamic forces, okay. So we have to maintain the control. That object has to be floated in a particular altitude. Then it has to be controlled with how it can be controlled. You have to be that weight adjustment. Okay. So everything has to be controlled. Then only you can overall flow phenomena will be controlled. Basically, you have a center of gravity which will be there. Okay. So your overall flow will be your flight has to be balanced. Okay. With respect to the overall weight of your particular flying object. Okay. So now what happened? Sustained turn. The sustained turn which already we have seen. What is there? We have seen the sustained turn. A flight which is moving in a particular zone and suddenly it has to change the path. So it has to change the path without affecting that curved turn it has to take. How it can be turned? So some of the flight which will lose the stability because air, it is interacting with the air. When it's a sudden pressure drop or change in the air pressure on the particular flight thing, what will happen? There will be a cause of instability phenomena. So in order to do that, we have to your forces, only your wings has to be just tilted and it has to be rotated. So that forces, the force acting on the aircraft in the sustained turn. So these are the forces which will be there. Then with respect to your weight orientation, your object has to be balanced in the particular altitude. So now vortex lattice method, what happened? That it will be lattices. Lattices, you know, that will be box structure. Okay. You can segregate your particular zone. Okay. So what are the things will be there? Lattice method. So lattice method, which will have a 1 minute. So what happened? It will deal with your kinematics of fluid. Okay, continuity equation already you know. Okay, basic continuity flow equation you have to understand. Then Bernoulli's potential flow theory, Helmholtz theorem, and Katowiczowski theory. and boundary condition and Biot-Savart law and horseshoe vortex. Horseshoe vortex, you may know. Actually, vortex will be generated with respect to P type, S type, and multiple type, and this horseshoe type, which we have seen in that earlier version. Okay. So earlier, the horseshoe type, how it will be impacted on your, where it will be, somewhere it will be there. Okay, I'll show. The horseshoe formation of your particular vortex generation. Okay, vortices which will disturbance, what will have interaction between the vortices, which will lead to creation of a turbulence, more turbulent, more vortex shedding phenomena. Okay, vortex shedding which will lead to more turbulence or instability in the nature. Okay, so then what will happen? We have to have a different vortex lattice method and theorem based on that particular method. So now we have to move towards the classical vortices method. Why we have to move to a classical vortices method? That wings basically, your wings is helpful for your lifting and drag, and all the force coefficient is mainly focused on your drag and flutter plates and everything. So now we are understanding the flow phenomena, how it can be. You have to segregate the part of your particular wings. So wings are divided into lattice of panel. What happened? Where the each section, that horseshoe in the particular zone, how it is affecting or how it is distributed on the each panel. Okay, so you segregated. So how it can be done? So bounded vortex of horseshoe is placed on the 1/4 of the chord length. So overall length is your chord length, and that particular line you can put up your particular horseshoe vortex is generated at the particular point. So what happened? The control point. Okay, this will be your particular one zone, like a finite element study you have studied. Na? So that particular cell zone, that particular point, that will be placed on the 3/4 of the chord line. Okay, so each panel at the midpoint of spanwise direction. So throughout the length of the direction. Okay, so you have to understand the flow nature and the generation of the vortex and its impact on the your main forces, your drag and lift forces. Okay. So now what happened? You have to use the lift, everything lift generated, that has to be analyzed using your Joukowsky theorem. And what happened when we have a lift generated, and apart from that, you have to see the main component in your drone design is the pulling forces, that is your drag. So drag will be how it can be identified and how it can be impacted on your particular things. So drag, where it will be there? It will be there in your wing, tail. Okay. So then fuse, nacelles, and other miscellaneous particular component. Okay. So what are the components of contributions for the drag? It has to be the summation of your particular, that is a strut. Okay. Yes, for strut and remaining thing. Okay. So what will happen? That drag applied on the all the component, you will be with respect to the strut, you will identify the components of drag contribution to the particular drone design. Okay. So now what happens? Skin friction factor. Okay. So skin friction factor. So friction factor, flat plate skin friction coefficient. How it will be there? They already we have a particular conditions. Okay, for different. It is a flat plate. So if I return a instead of flat plate, circular and other thing, we have a aerodynamic profile and we consider that as a flat plate. So what is a flat plate? That flat plate has been defined and earlier. Okay, that has been for already we have given the different skin friction factors and your factors has been mentioned in the earlier version. Okay, so earlier some of the charts are there. So predefined factor for different components and different objects. Okay, so with respect to different structures, skin friction factors will be modified. I already predefined value. Okay. So for circular object, then form factor for the different component. So you have to understand what is happening in your form factor at the wing, tail, strut, and pylon. Okay. Then what happened? Fuselage and flow nature of your particular, whether the smooth nature are there. Then nacelle. Nacelle will be your start nozzle part of your particular flow parameter. When your aerodynamics is there, that will be basically your fluids and everything which will be diverted or extended or it has been separated. The flow is separated at the nacelle region. It is first part of your nacelle is going to interact with the flow. Okay, when it is going against the fluid. Okay, so then we have to identify multiple factors. So here we have seen skin friction factor and everything. Then we have a interference factor. So for different fuselage, your that storage, that fuel tank. Okay, then it will be having water. That interference factor is 1. and one for wing and nacelle. For different structure, there is a different your interference factor will be there that can be used for calculation. So these are the theoretical calculation. So we have spoken about theoretical calculation. What is the significance when we are moving towards a significance of applying the computational aspect for the development of design of a aerodynamic, like aerial vehicle or any automobiles, okay, which has to go against the nature of aerodynamic forces, okay. So what will happen? The computational fluid dynamics, which will based upon your physics of fluid conservation, okay, energy transfer, okay. So a mass transfer, energy transfer, multiple thing. Your flow conservation equation, it will be defined, okay. Then what happened? Basically, you have a Navier-Stokes equation, then Reynolds the average Navier-Stokes equation, then multiple things will be there. So you have to discretize formed. What is a discretized formed? You have to discretize the form, whether it is a finite volume method, it is a finite difference method, or whether it has to be solved in a finite element method. Okay. So then what happened? You have to make that grids and everything. Computational you may have done already. Integrants, interference, independent study, everything you have to do. Why grid independent study we have to do? We have to do the grid independence, whether our problems or the designed object, which is, okay, we have a designed object, but it can be a multiple zone, multiple grid. It has to provide the same result on the without affecting the nature. Okay, there may be a minor variation. Okay, so that has to be a grid indifference. Then you will solve using your commercial version or your program you have developed. Okay, it may be an open form program for the particular condition. Then you will get a particular result out of it. Okay. So now normally there is a turbulence will be there. So to follow the turbulence, because the fluid structure interaction at a different flow rate, there will be cause of your turbulent flow nature. Okay, perturbance development. Okay. So because why? What are the different methods are there? There is a direct numerical simulations, DNS. Okay, scaled revolving simulation, SRS. Okay, Reynolds average Navier-Stokes simulation. So now what happens? Scaled simulation, what happened? There is a multiple scales will be there. So it will be what happened? It will to identify the eddy formulation. Okay, multiple eddy formulation or three-dimensional aspect of your flow phenomena with respect to each. So multiple in between subscales will be formulation. Subscale, okay, subscale phenomena. It will be added multiple scenario which will added to support the thing. So what are the things will be there? Large eddy simulation. And there is a hybrid RANS and LES simulation. We have a Reynolds average Navier-Stokes equation. Then along with your hybrid, okay, what happened? LES and RANS, you will have to solve detached eddy simulation. There is a large eddy simulation and detached eddy simulation. Then scale adaptive simulation and partially average Navier-Stokes simulation. Okay. So normally when we have a solving, we will use then RANS equation. Okay, use in which multiple condition. Now it will come multiple conditions. Okay, so when you go for a RANS model, what are things will be there? You have to see the eddy viscosity model. Okay, Reynolds stress model. So now what are the things when you go for eddy viscosity model? That is a equation based model. So plot Almaraz model, one equation model or two equation model or two equation k epsilon or k omega. Okay. So transition model that will have a 7 equation. So depend upon why these equations are there to in order to solve the problem and in order to get multiple solution out of it. Okay, we have a multiple solution, multiple problem and multiple condition we have to satisfy. Okay. So now what happened? Your k epsilon model that will be standard k epsilon, RANS, kg, reliable k epsilon models are there. Then k omega model, that is a two equation model, standard k omega and generalized k omega with SST. Okay. SST models are there. Then what will happen? We have a 7 equation models are there. What will be? There is a transition model of 3 and 4 k omega. Okay. Then epsilon and omega and combined together intermittent transition model. Okay. SST subscale transport phenomena. Okay. Transportive nature of the flow phenomena has to be understood. So now there is a thing. We have multiple number of softwares and solutions to have a for sustainable development of your drone designs and everything. So now what happened? We have a VLM. What is VLM? Your vortex. Okay, vortex lattice method. What is vortex lattice method? We segregated your wings into particular lattice and identifying the impact of your particular vortex is generated. What is generated in the particular zonal conditions. So now Now what happened? We have to think about what are the things we have to think. So when any one of you going to design any component, so what will be their basic phenomena? You have a mechanical engineer. We design the component. We design the particular aerodynamic solution. So in ANSYS, how we will do? We will design the aerofoil or particular aerofoil, or you can design the whole object. Okay. So then what will happen? We will make a computational domain with boundaries. Okay, whether it has to be a medium, you have to flow medium, everything you set up, then you will make a grid formulation. Okay, your discretization you have to do, then you have to formulation of your grid. Okay, whether you have to find grid or multiple, you to formulate, then you will go to your solution, then you will solve accordingly, and you will get the major parameter. Okay, here one of the parameter we have to win designing the geometry itself, whether the flat wings are moving or not. There is a flutter plate has been moving at a different angle, because your angle of attack is going to be play a significant role in your flow phenomena. Okay. So now what happened here? Instead of using a ANSYS software, there is a software called that VSP Aero. Okay. So NASA and everything, foreign countries, they have been utilizing for this drone development. So what will be there? This VSP Aero, you can set up similar to your ANSYS, but here we can identify multiple parameters. So now what are the things are there? We have to generate a geometry. That geometry can be generated through any two-dimensional or three-dimensional software. So how you want to apply, whether you are going to solve a two-dimensional or three-dimensional, then you put up the setup. Okay. So we have trim analysis there. I will say trim analysis what exactly with the show of the figure. So I have designed a component. Okay. This is my aerofoil or aero drone. So design specification created VSP model. Okay. So what are this thing? This aerofoil blade profile, which is made of NACA 7601, span length of 30 meter, chord root tip that is 1.6 to 0.8, and area of 36. Okay. Then incidence of sweep 4 to 1. Okay. That sweep diagonal, take everything, and ratio of TC ratio, then fuselage that is 16 and everything. Multiple condition, your multiple parameter you have kept about that. Multiple components will be there. Everything you have to that design specification. You have designed. This is your part, and you design the component. Okay. So now what happened? There is a software VSP Aero. Now you have to go there. You have to give the there is a method. When you go for what is the method we are going to use, that is a what is lattice method. So we have to go for different wings, area, everything. We controlled everything. Okay. So now we have to define the drag coefficient on the particular wing. We may have wings. Okay. We may have stabilizers, because your aeroplane which will have a stabilizer, normal stabilizer. Okay. That will, if it is malfunction, your a flight won't have a proper stability. It will go like floating in a like a water. Okay. Boat floating in a different turbulent nature. You have seen the boats traveled in a water area. What will happen? High end waves which will disturb, and the nature of the will be more disturbed. Okay. There also stabilizer will be there, but beyond that, when you go for an aeroplane, what will happen? The drone and other component which will have more, which will need more stability. So that stabilizer will be there. How you are going to put, and what are the basic parameters? Okay, multiple formulation will be there. Then what are the form factors? What are the drag coefficient? Everything you have to formulate over the particular thing. Okay. So how different you are giving the multiple conditions with respect to the condition, how it is going to analysis. So now what happened? We have generated multiple nodes generated. So it has to be, we are understanding the grid sensitivity analysis or grid independent analysis. Okay. So now we have to identify. So what happened? You have a different number of nodes, 6,000, okay, 10,000, 21,000, but varying at angle of attack 7 degree, here -4 degree. Okay. Your angle of attack is varying. So normally what you are seeing, different nodes, your lift coefficient is 1.9, 2.10, 2.042, and your lift difference is how much it is different. Okay. So then what will happen? 0.0534 induced drag which is generated. So overall difference in the coefficients, what will be there? So now what happened? We have to measure whether it is significant. It is not too much difference. Okay. So when you understand there is a minor variation, then your grid developed is having a sensitive. It is an independent grid, so you can solve any your design and which have a proper grid ratio, you can solve. If it is varying 0.5 to 0.8, 0.9, and here there is a 3, 10, like that, multiple variation will be there, then your grid is not independent and it has to be solved more and it has to be analyzed more. That may be lead to multiple problems. Okay, multiple design issues and calculation will be there. Okay, 1 minute. So now you have what happened? You generated your grid on the particular structures. Okay. So now what happened? You have to trim. What is the trim analysis? Any one of you? Why we have to do trim? We have to trim analysis. What happened? Your object may not have a, in any object, the design, your design. We have to understand any other particular component or particular misalignment or some other thing. You have to understand whether your object having properly designed and it may not have any effect on the flow nature. So now we have a different flutters and everything, wings, everything will be there. Okay. So now what happened? Whether any part of the thing, what is there? What is exactly happening here? There is a gap in the particular engine fuselage. That engine fuselage is there, na? That fuel will be supplied and that engine will blow and it will give the thrust. But what is happening here? There is a significant gap in the particular zone. Okay? So what will provide CAD geometry earlier? But what happened? It has to be merged. If there is some disturbance in that subject, it will lead to what will happen? Instability or failure of the particular component. Normally, as a mechanical engineer, we know if where the stress will be concentrated, it will concentrate on the weak spot. It may have it. So we have to design a component with less holes and everything. You may have studied already in your different classes. Okay. So now what happened? We have to analyze, trim wherever required. We have to modify the final correction. Okay, because if your design is not proper or combined, that continuation will be there. Your grid won't be generated. Okay, so your geometry, that grid will be into like there is a significant difference in your grid, and some of the part may not be generated. So there won't be any meshing won't be happen. Then what will happen? It will lead to impact the overall analysis of your final solutions. Okay. So now we designed a particular component, we done everything to analyze all or not? Tangavil sir.
Sir, yes, sir, you can proceed.
Okay, actually, some of your friends are some very good person. They removed me from that meeting. I don't know who done
Sorry
that.
for the
Okay,
inconvenience, sir.
just
Okay,
change the
okay,
meeting
yes,
option, sir.
Okay, no issue. Thank you so much.
thank you, sir.
Yes, sir.
I don't know where I have been there. Which part? Any one of you? Whether I have been. Actually, I'm in lecture. Okay, I will call you after 11:30.
Sir,
Tell
the
me
previous
where
slide, sir.
exactly I have this slide.
Sir, next one, sir. Next one.
Slide. You have seen this thing?
Sir, Paavai, sir. Yes, sir. So I think this one, sir. This one. Previous one.
Okay.
Okay, sir.
Okay, thank you. I'll start from me. Okay. Okay, no issue. So what will happen? We have to design, when you have to design everything in order to have a continuity of your simulation, everything, because your grid, once you discretize and you have a grid formulation, that grid is important to solve the failure and other thing, flow nature, when the flow has been distributed or significantly impacted on your particular structure. Okay. So now what happened? Your structure has to be analyzed properly. Now what happened? Your structure, whether it is completed, connected continuously. If there is any gap or any hole or structure, as a mechanical engineer, we may know that your forces applied on any object, that stress strain formulation, which will be more on the weaker zone. That weaker zone may be more impacted to the holes and other thing which are in the, if you have a flat plate, that stress instead of corner, it will go to your holes in the particular thing, then it will go to the particular corner, more stress concentration. Like that, you have to design the object, design the parameter in an efficient manner. So in order to avoid the unnecessary discontinuity, you can design your component. Okay, earlier it may be a flat. Okay, then you can design the component with respect to attach for the fuselage setup. Then you design and you do the continuation of the particular product. When we have a design, when we designed
Sir?
everything, that yes,
Sir?
yes.
Sir, just 1 minute, sir. I'll just change the meeting options. 1 minute, sir, please.
Okay.
Sir, you can please proceed, sir. Thank you.
Yes. Okay. I hope we have designed all the object and we like a formulation of your mesh. Okay, we have a clear mesh. Now what happened? We have to, what will happen before doing this thing? We need to put up the particular, we understand your component is neat and everything. It don't have any geometry has been very neatly derived, and it will have a, you have a confidence that your design will be best. Now half an hour. Another. Okay. What will happen? We have to understand. So now what happened? We need a domain too, because in order to understand the flow phenomena and effect on your particular component, we need to identify the that boundary conditions. What are the boundary conditions we have to fix? So that boundary conditions has to be fixed properly. So then further we will analyze, we will generate them, because once you define your component is okay, then you put up the component inside your domain, and what will happen? You have to formulate. Okay, you have to identify, set up the boundary. Okay, all other zone, whether it is where the, in order to why this particular things are very near. Okay, when you generated different cell zone or cell conditions near the bound, near the particular component, and at the different region, because we need to identify where the flow separation has been happening in the particular component, whether it is happening at the particular tail region or where exactly the vortex, in order to identify the generated vortex phenomena at the particular point. Okay. So now what happened? We already, it is the same thing when you have utilized your ANSYS software. So to understand the sustained, in order to maintain the sustained return, we have to see the maximum load factor. Okay, then similarity for it is for your stabilizer. Okay, it has to, your stabilizer which will have a particular point. It is basically depend upon your different parameter that has been approximately it will be 1.127 or that maximum load factor will be 1.40. Then there is a multiple pressure based solver, and what type of model you are going to, Spot, Almaraz, K epsilon, K omega model. It is similar to what you have done in your particular ANSYS and other software hybrid initialization. Okay. So then you will understand, you will finally, you will solve the particular problem. So what are the different things will be there? More number of, we have a fuselage, that engine outlet. What will happen? There is a different flow phenomena or change of phenomena. Okay, high pressure contribution near the boundary you can see. So once you understand what is the momentum and continuous transfer of flow, it is a conservation of energy equation. Okay, overall energy transfer and mass transfer, everything you will understand. At a different point we have to identify for different meshing condition, what is the value we have get and what are the effective solution out of it. Okay, so these are the main region when you have an application of CFD matter. Okay, when more concentration of stress at a particular point, what will be there? If in the fuselage region more stresses will be concentrated at different point, it will lead to the failure of the component. Then what will happen? If your aerofoil is there, if there is a accumulation of more drag or on the particular phenomena, okay, more drag phenomena, it will show. Okay, so that edges will be leading to that accumulation of forces at the particular edge. Here you can see a smooth flow or equal distribution of pressure, force or velocity on the particular component. Then you can see there is a variation on the nasal zone, different conditions. Okay, you can understand about the, it will be like a velocity plus. Okay, then you can understand what will be your pressure difference, what will be your temperature. You can understand the temperature variation at the particular, because your object is going to interact with the particular structure. There is a skin friction. There is going to be a friction between the flow nature. Okay, your air or wind, it is going to interact with your particular object. What will happen? There is a friction generation. With respect to the friction generated, there is a heat formulation at the different part of your, what we are seeing, we have an engine inlet, outlet, antenna, forward, rear, okay, tail point and everything. So multiple portion, how the temperature difference, how it is significant to the overall flow nature. Okay, how it is impacting on your overall flow domain. So then only we can design. Then other aspect, what are the other aspect? So we have a drag coefficient. When we add multiple point to it, when you are design, which will have a multiple loading condition. So when it is going for a defense sector and other aspect, what we have to do? We will add multiple loading condition. We may have a logistic when we have to transfer particular weapon system or weapon block or food, everything. We have to add the additional loading condition to the downside of your particular drone. What will happen? It will give additional drag to the particular, because gravity is going to pull your component flight and your lift is going to be needed higher. So how it can be improved? So whether you need an initial push throughout the fuselage, whether I am going to initial push or thrust. Okay, anything we needed initial push. Okay, so that push may be higher requirement and high fuselage push needed, then what type of arrangement we have to done? Other than that, what are the other extraordinary condition that will influence your drag coefficient? Okay, in order to, we need a lift, and
Sir, sorry for the inconvenience, sir. சார் உங்களை மியூட்ல இருக்கு சார், அன்மியூட் பண்ணுங்க.
I think someone don't want to listen to the lecture. I don't know who is doing this thing. They are doing great job, because I'm not muting or I'm not moving away this from this lecture.
Yes, sir. Yes, sir. Yes, sir. That's I know, sir. But we are trying to change the settings, sir. But we can't, sir. Sorry for that, sir. You can proceed, sir. Now.
Over interested, they can contact me later also. Okay, no issue. Okay, this is for different flying condition, different patrol condition, different flying condition, so different operating condition and different angle of attack. So what will happen? Negative, positive, and it has to be understood, because your stability of the flow phenomena and sustained turn, it has to withstand. Okay, after different analysis. Okay, so then we will do with, along with you similar analysis you can do with your commercial version of your ANSYS software. You can understand, analyze the solution out of it. So what will happen? You will have a better solution how it can be managed. Okay, so you have a better design out of it. So these are some of the results out of it. How the drag, induced drag, how it is influenced in your particular component. Okay, so now what happened? What is this? Is a recirculate region of greater angle, different angle of attack. How the flow separation has been happened at 4 degree, 5 degree, and 6 degree of angle of attack. And what will happen? This is a pressure variation. Okay, you see the object where the pressure accumulated in the top region of the particular part and your nasal region. Okay, so where are the different part and your fuselage area? Okay, you see the fuselage area, top or bottom. Here your bottom view. Okay, and your top of your particular fuselage will be there, and different zonal condition, your pressure variation at one condition. Multiple design will be there. Okay, so multiple condition, multiple solving. Okay, so we'll get the only thing we have to understand final product. We have to need the, what is the thing? We have to generate a drone that has to minimal application. When you use for spy application, the defense corridor, it may not need a multiple weight loading capacity. But when it is a multi-purpose drone design, it has to carry, it has to survey, it has to do all the aspect. Okay, so then you have to design for multiple zonal condition, climatic condition, variation. So climate, which will involve, what will be there? There will be a flow nature, velocity, different flow phenomena will be there. Then what is? It can be either your temperature variance, pressure variance. Okay, because it has to travel different altitude and different region. Okay, and apart from that, you have to have that overall material characteristics also you have to design, because your flow nature has to be more smooth. Okay, when it is not smooth, it will create more turbulence in the particular domain. Okay, so these are the things which we have to design. Okay, these are that rudder you may have seen in the rudder. What is a rudder? It will help you to different flow separation of your particular deflection. Okay, it can useful for your lift and drag part of your particular thing. Okay, different angle of you can change. You may have seen in an aeroplane that may be visible from the pot. Okay, so these are the things in your initial drone design and analysis will be there. What are the basic things you have to consider? So at present, we are working on wind and wave energy conversion in our laboratory. So if you have any doubt or future any idea to join our program, you try to clear GATE score, UGC net or CSIR net. So if you have a valid GATE net score, you will have a stipend of 3742 like that. Depend upon the program, JRF or SRF you are going to join. And if you are joining for MTech program, we have a MTech, very good MTech program. So you can join in our MTech program. So first 4 people will be having eligible for some international South Asian Foundation sponsorship, complete fees waiving. So that part will be there. So these are the things. Once again, I thank the management and organizer, head of the department, convener, and everything for giving the wonderful opportunity. So I'm concluding my session.
Thank you, sir. We hope your knowledge is facilitated the excellence of Paavai. I wish to call upon Mr. Mohan Raj from second year mechanical engineering to present the vote of thanks.
A very good morning to all. I begin with my sincere thanks to our Honorable Chairman Sir and beloved Correspondent Madam for their encouragement and constructive inputs towards the success of this program. Thank you, sir. Thank you, ma'am. I thank our esteemed Chief Guest, Dr. K. Karthik Selvakumar, Assistant Professor, Department of Green Energy Technology, Madanjit School of Green Energy Technology, Pondicherry University, a central university and under Ministry of Education, for spending his valuable time with us to enrich our knowledge despite his demanding commitments. Thank you, sir. I extend my sincere thanks to Director Administration for his timely support in organizing this program successfully. Thank you, sir. I extend my heartfelt thanks to our principal for his continuous inputs and encouragement to ensure the success of this program. Thank you, sir. I extend my sincere thanks to our HOD for his guidance to make the program a successful one. Thank you, sir. I thank all to HODs, faculty members, and non-teaching staffs of Paavai institutions for leading their helping hands. Thank you, sir. Finally, I thank our brothers and sisters and all other supporting staffs for their cooperation and providing the required faculties. Thank you. Once again, thank you all.
अभी खत्म हो गया, होने वाला है, 2 मिनट ओके, खत्म होगा.
So thank you, sir. Thank you so much.
Okay, thank you. Can I leave the
Okay.
session?
Yeah, sir. Yeah, sir. Sure, sir.
Okay.
Thank you, sir. Thank you.